Hi everyone. We've got this practice test here, practice test 14. First part, numbers 1 through 7 deal with f of x being x squared plus minus 2x plus 7, g of x equals x minus 3. Now these are operations on functions. We're just going to add, subtract, multiply, and divide. And we'll ask a little question there. And then we have composition of functions that we'll deal with here. And f plus g of x. That's simply f of x plus g of x. And f of x is x squared minus 2x plus 7. And g of x is x minus 3. And then we will just combine like terms. I got the x squared, negative 2x plus 1x is negative 1x. And 7 minus 3 is 4. So f plus g of x is equal to x squared minus x plus 4. I like to put it up here. Okay, now f minus g of x, that's f of x minus g of x. So I'm going to take the x squared minus 2x plus 7 and subtract x minus 3. And I'm going to take out parentheses this time. Minus 2x plus 7. Go minus x and then plus 3. I have the x squared. Negative 2x minus x. That's negative 3x. 7 plus 3. That's 10. So f minus g of x is x squared minus 3x plus 10. Now f times g of x, that's f of x times g of x. Now this isn't the circle like this is, so just note the difference. That just means multiply. F of x is x squared minus 2x plus 7, and g of x is x minus 3. I'm going to make a box for this one. I have x here, negative 3 here, x squared, negative 2x, and 7. X squared times x is x cubed. Negative 2x times x is negative 2x squared. 7 times x is 7x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 2x is 6x. Negative 3 times 7 is negative 21. Alright, so I got the x cubed. Negative 3x squared and negative 2x squared is negative 5x squared. 7x and 6x is 13x. And then minus 21. Now f over g of x, that's f of x over g of x. So f of x is still x squared minus 2x plus 7 over g of x, which is x minus 3. And that's all we have to do with that. X squared minus 2x plus 7 over x minus 3. This doesn't factor, so we can't simplify like that. Now, number 4 is f over g of x. Number 5 is asking for the domain of f over g of x. So I want you to look. We can't have the denominator cannot equal 0. If I add 3 here, it says x cannot equal 3. So the domain is all real numbers except 3. Okay, this is the composite functions we've been dealing with more. That's f of g of x, f circle g of x, f of g of x. That is f of x minus 3. So I am going to replace the, let me just try something here. You got f of x is equal to x squared minus 2x plus 7. Now I'm going to replace so we're doing f of x minus 3. I'm going to replace the x's with x minus 3's. These two places that had x's, and then the plus 7. X minus 3 squared, I'm going to do it right here. That's x squared, that's minus 6x. Outside is minus 3x. Inside is minus 3x. And last, negative 3 and negative 3. Negative 3 times negative 3 is 9. And those two make negative 6x. So that's x squared minus 6x plus 9. Negative 2 times x, I'm distributing, is negative 2x. Negative 2 times negative 3 is positive 6. And then I still have this plus 7. Alright, so I have an x squared. Now negative 6x minus 2x is minus 8x. 9 plus 6 is 15 plus 7 is 22. This is what f circle g of x is equal to. Alright, now this is g of f of 3. Now f of 3 is equal to 3 squared minus 2 times 3 plus 7. Taking the x's out, putting 3's in. That's 9 minus 6 plus 7. 3 plus 7, that's 10. So now we're going to find g of 10. F of 3 is 10. Let's find g of 10. And g of 10, well, g of x is x minus 3. G of 10 is equal to 10 minus 3, so this is 7. Okay. The one-to-one functions. Okay. That means their inverses are functions. That means they pass the horizontal line test if they're one-to-one. All of these are functions. They pass the vertical line test. This one passes the horizontal line test, so I'm going to circle it. Its inverse is a function. This one does not pass the horizontal line test, so that one doesn't pass. This one does not pass the horizontal line test. This one does pass, even right here it's passing the horizontal line test. So I'm going to circle this one. This is a one-to-one function, this is a one-to-one function. These two are not. This one, it definitely passes the horizontal line test. It is a one-to-one function. Okay, now 9 through 11, find the inverses. Okay, remember, change the f of x to y equals 3x plus 1. Switch the x and the y, so I'm going to put x here where y was and put y here where x was plus 1, and solve for y. Get y by itself. I'll subtract 1 from both sides. I have x minus 1 equals 3y, and I'll divide by 3. So I have y equals x minus 1 over 3, and then I use the inverse function notation, inverse of a function notation. Okay. 10, same directions. 9 through 11, we're finding the inverses. So y equals x squared minus 2. Switch where x and y are. X equals y squared minus 2. Solve for y. Let's add 2 to both sides first. X plus 2 equals y squared. I'm going to take the square root of y squared. That's how you get rid of the square. And that's plus or minus the square root of x plus 2. So I have y equals plus or minus the square root of x plus 2. And then my inverse function notation, inverse function of f of x is plus or minus the square root of x plus 2. And last one here, y equals x plus 4 over 2 means x equals y plus 4 over 2. I'm going to multiply both sides by 2 first because I'm solving for y. 2x equals, those cancel, y plus 4. I'm subtracting 4. I have 2x minus 4 equals y. Alright, I'm going to use inverse function notation. Inverse of function x is equal to 2x minus 4. I kind of stumbled over the words there. Alright, this one. Determine whether the following pairs of functions are inverses or not. Show your work. I don't know if you remember, this is the last thing we did. F of g of x, if it equals x, and if g circle f of x is equal to x, then they are functions. So let's find f, then they are inverse functions. Sorry, these two are functions. Are they inverse functions? F circle g of x is f of g of x, which is f of 1/4 x plus 3. Okay, the f function. So we're going to take 4, put in 1/4 x plus 3, and then subtract 6. So 4 times 1/4 x, that is x. And 4 times 3, that's plus 12, and that's minus 6. So that's x plus 6. This is not equal to x. Therefore, or so, f of x and g of x are not inverses. Okay. Let's give 13 a shot here. Same thing, f circle g of x. We're going to see if this is equal to x. That's f of the square root of x minus 1, which equals, okay, we're putting this into the f function. Take the x out, so I got the square root of x minus 1. I'm going to square that and add 1. Okay, when I do that, the square root and the square cancel out. So that leaves me with just x minus 1 here, and then plus 1, which equals x. So that's promising. G circle f of x, that's g of x squared plus 1. That's what f of x is. So in the g function, I'm taking the x out, putting x squared plus 1 in its place. So here's where x was. Let's put x squared plus 1, and then you have this minus 1. It's a square root of x squared. It's plus 1 minus 0, which is x. Okay, so f of x and g of x are inverse functions because they both equal x in their composite functions. All right, let's try number 14. F circle g of x is equal to f of 3 square root of x. That's what g of x is. I kind of skipped a step. I didn't. No, I'm doing all right. So f says you got your 9 here, and then you have your x squared here. Well, this is what is replacing x. So I'm going to square that. So that is 9 times 3 squared is 9. The square root of x squared is x. That's 81x. Definitely not equal to x. F of x and g of x are not inverses. Okay, there we have it, guys.